Okay, part 3. We're going to do some examples of force components, and basically what we're going to do for this is find the force. Sometimes if you think about some engineering stuff, it's no more than just a puzzle of trying to sort things out and see where we're going, that sort of stuff. Alright, we're going to keep this one relatively simple. I'm going to work in just 2 dimensions and try to help keep this simple. Alright, I want to do this. We're going to draw our x-axis, and then we're going to draw the y-axis. And I'm going to do, I'm going to draw it with a little bit overhanging the negative y, just so that it helps you out. Okay? Come on, get out of there. And give me, what do I got for an angle on this thing? Bum, bum, bum. I don't know the angle. Well, that's so much cooler. Okay. But I do know it's 16 this way. So there's my origin. Let's do the vectors in red. I'm going to go 10. Actually, tell you what, I'm going to go 5, 10, 15, and that would be 20. So that would be 16 to there. Actually, it'd be nice to get that on the line. Alright. Let's do it this way. 5, 10, 15, 16. There. Okay. And I will draw an arrow there. I'll come back and label that in a minute. And I am 12 down. Okay. So we're going to go over here to 90. And we're coming down 12. 5, 10, 12. And back up. Okay. And then the interesting thing is it's find it in this direction. Okay. So this is the force vector equal to 200 pounds. Okay. And I can get rid of the ruler for a bit here, and I'm going to shrink this back down to size. Okay, so I know this component here, f of x, and this has a distance of 16 feet, and this is f of y, and this has a distance of 12 feet. And other than this will be negative, just to keep the world somewhat straight, we can actually find this for simple fact that this is a 3, 4, 5 triangle. So let's just do that for a second and keep this in mind. So if I do this, f of x, that's 16 feet. This is 12 feet. Okay, tip to tail again. And that means my hypotenuse for this thing has to be 20 feet. So that's 3, that's 4, that makes that 5. Keep the proportions the same, and you have a 3, 4, 5 triangle. All right, and that gets 90 degrees in there. That helps us, but it's not the sole entity of everything we're doing here, okay? But I am going to do this. We're going to take the origin, and we're going to label that as A. We're going to label this as C, and we're going to label that point as B. Okay? Now, here's where the investigation and the fun comes into this puzzle. So if I do AC, the line AC, and we know that's 16 feet, okay, and we do CB, and we know that's 12 feet. Oh, I need a line over top of that. And then I'm looking for the distance of AB. Technically, it's unknown, and we can solve it a lot of ways. But simply the fact that it's a 3, 4, 5 triangle, then we know this turns out to be 20 feet. If you need some help with a 3, 4, 5 triangle and understanding that concept, give me a chat and we can talk about it. But other than that, it's just some simple math. Go back and review a little bit of trigonometry and you'll have it. But you could also find it by doing this. C squared is equal to A squared plus B squared. Or in terms of what I got up here, AB squared is equal to AC squared plus CB squared, and we'd find that all out once you just do the substitution in there. Okay, so either way it'll get you where you're going, and it's important to know that because we're going to use that to verify things, and as long as we're here, what the heck, let's have. Alright, so we got 16 squared plus 12 squared, and if we take the square root of that, that gives us AB, and we will find out that is 20 feet. Okay, so hence the reason that's all there. Okay. It's important to know the hypotenuse because we're going to use that while we're playing with the cosines of all this stuff. All right, and I'm going to go back up here with one other additional piece of information we're going to be looking for, and it's this, and it's the alpha. We're going to play with alpha instead of theta in this one. Okay, so cosine of alpha is equal to 16 over AB. Okay, and the cosine of alpha is 16 over 20, or 4 over 5. And if we take 4/5 and turn it into a decimal, or just be able to look that up, we're going to find alpha is equal to cosine arc of 4/5, and alpha will be equal to 36.87 degrees. Okay, that's useful. Now, along the way, whoops, I don't want cosine, I want to use the sine value now. So the sine of alpha is equal to 12 over AB, and that will lead us to sine of alpha is equal to 12 over 20 equal to 3/5, and alpha is equal to the arc sine of 3/5, which is also 36.87 degrees. So either one of those two will get you where you're going. I just wanted to review some math with you. Primarily, you can just do the cosine and you should be good. Okay. Now, let's go look at the vectors here. All right. And we're going to look for f of x is equal to f cosine of theta x, which is also 200 pounds. Okay, and I'm going to put the plus sign in here so you remember to do that, times 4/5. Okay, so I didn't actually need the angles to do this part, but the angles will come in handy down the road. But just remember, cosine, and I'm doing it again. Let's stick with the right signs here. alpha x. Cosine of alpha x is equal to 4/5. That was from right there, okay? And I'm going to write this out in its final answer, and I'm going to get a positive 160 pounds, okay? And if I do the same thing for f of y, I am going to get f cosine of alpha y, and that's going to be equal to a negative 200 pounds, and that'll be 3/5, okay? And that'll be a negative 120 pounds. Okay, so a couple little things here is you can do this a variety of ways, okay? I know that cosine alpha y is equal to the sine of alpha x, all right, and that'd be 3/5. You can do this a couple ways. You could have rewritten this as the sine of alpha and then use the 3/5, but we've got to watch your signs and your trig orientation here, okay? All right, the next thing is I can actually do this in terms of the unit vector now. So f is equal to f of x, okay, times I. And now because I put the unit vector I in there, I don't need the little vector symbol over top of this, is equal to f of y j, okay? And we can literally plug in our answers from over here. So this is positive 160 I minus 120. Whoops. You know what I got to do? Sorry, folks. I'm a stickler for this, and I'm getting away with not doing it. Write your units in. I minus 120 pounds. And if it helps you, put parentheses around things. Your J. That's a lousy J. Okay? And that'll help you keep some stuff straight there. Okay. All right. That gives us the answer to F. Okay, we don't have the final true answer to this, but I want you to get the hang of this and practice this, and then we'll come back and we'll do the next piece, which is finding the angles. Okay, and I'm going to pause the video, but I'm going to leave this on the screen and come back with this in the end. Okay.